Hello everybody, this is problem 4011, the squirrel problem. Part A, what time interval from 0 to 18, if any, does the squirrel change direction? Give a reason for your answer. Well, reading the little problem there, this is a graph of the velocity of the squirrel who starts at building A at time 0 and travels along a wire connected to building B. So when does the squirrel change direction? Well, that's pretty easy. So here's the rubric. The squirrel changes direction at 9 and 15. So here is 9, here is 15, and the values is worth 1 point, the 9 and 15, and why does it happen? Because the velocity changes sign at those points. You could obviously say in detail, the velocity changes from positive to negative at 9 and from negative to positive at 15, but all you need to do is say that it changes sign. That's good enough to get your second point on this part. For part B, at what time interval from 0 to 18 is the squirrel farthest from the building? Well, farthest is screaming out optimization, max and min, so you need to find a max or a min at this point. So if I were to graph really quickly in my ideas the squirrel's position, since the velocity is positive at this point, it's going up. And then when it changes direction at 9, it's going down. And then it changes direction again at 15. And then it's here. So the biggest two most important pieces are this piece and this piece. Which one's higher? That's my plan I'm formulating in my mind. So as we start off, there's a couple different ways to do this. The easiest way always is to make a table. So starting at 0, the position is 0. Now if you refute this and say it's a local minimum due to the velocity being positive on the right of that endpoint, well, you don't need to have 0, 0. And likewise, the minimum is 15. You could refute that by saying, well, since the velocity changes from negative to positive, that's a local minimum, so you technically don't have to check those if you refute those by saying that they're local minimums. The candidates that are most important are 9 and 18. So identifying the candidates, if you have 0, 9, 15, and 18, that's perfectly fine. That's a really good idea. But if you only have 9 and 18, because you say something like 0 and 15 don't count, or 9 and 18 are the only local maximums, those are the only two I need to compare, then you just need to compare the positions. Well, the position at 9 is 140. So how did we get that? There's lots of ways to get that. You could break this up into a triangle, and a rectangle, or you could just do a trapezoid. Trapezoid is 1/2 height times base 1 plus base 2. And you could figure out base 1 is this one, which is 9. Base 2 is this one, which is from 2 to 7, which is 5. 9 plus 5 is 14. The height is 20, because the height is like right here, how tall it is between the parallels. So half of 20 is 10, and then 10 times 14 is 140, and that's how you get the 140. I'm not going to do all the details again with 18, but you get the picture. You could take away this negative area by doing a trapezoid or rectangles and triangles, and then you could do this end one here by doing a trapezoid or a rectangle and a triangle. It doesn't really matter, but you're looking for those answers. The answer is, for this one, the question is, once again, at what time interval from 0 to 18 is the squirrel farthest right from the building? Well, the time interval, since 140 is the largest number, this is the final answer, but it's at what time interval, so you need the time interval, so at t equals 9, squirrel is farthest right. I'm not going to write that because I don't have a lot of room here. Squirrel is farthest right, and he is 140 feet from building, etc. Okay, so the answers would be the 9 and the 140, and the candidates would be the 9 and the 18, refuting your other local min. Part C, total distance the squirrel travels from 0 to 18. So total distance, remember, is always the integral. You want 0 to 18 here, and total distance, not displacement, so it's the absolute value of v of t. Okay, so that's the idea. So how do we execute that? What I just wrote is here, but you still need to get the answer. The answer is all this stuff, total distance. The key here is that this 140 is this amount here shown on the last slide. This is negative 50 with an integral. However, since it's negative and you want total distance, you need to absolute value it, so it changes to positive. And then this here is a little 25 area. So you add all those up. Your answer is the only thing you get points here for. You didn't even need to set it up like this, but it's good to remember that that's how you do total distance. Now for the last one, write expressions of the squirrel's acceleration, velocity, and distance from the building A. Now the acceleration and velocity are mildly easy. The distance is the tough one here to try to get those last 2 points. So let's reveal them. Reveal them one at a time here. So starting off for acceleration, I've highlighted the section that it's talking about here in red. Excuse me, from 7 to 10. So basically acceleration is the derivative of velocity. This is the graph of velocity, so it's a slope of the tangent line. So I just need the slope. So hopefully a lot of you make mistakes on the slopes. You did it correctly this time by doing the y minus y and then the x minus x on the bottom. I hope that you don't have this backwards. So it's 30 over 3. Negative, one of them being negative. So in this case, the way I set it up here is the bottom is negative, and you get a negative 10. So if you got something like 1/10, that's a big mistake, and many of you are doing that multiple times. So that's the acceleration. That's all you need. It's a number. Number is a negative 10. That's 0.1. 0.2 is the velocity. Well, this is the velocity function. I just need to come up with the equation of that red line. So how do I do that? Well, you need a point and a slope. So the slope you're already given is negative 10. I'm going to try and squeeze in my underlines here. So that's the slope, negative 10. And using either the point 720 or 10 negative 10, 720 is a little bit better. That's a perfectly fine answer from point slope form right here. Or if you really want to put in slope intercept form, you could combine everything and go like that. So that's the velocity point. Now here comes the position point. I want to highlight something for you. The position, the distance, I guess is what they call it, is not x sub 5, it's x sub t. So the thing you have to have in your answer is you have to have a t somewhere. So how do we get that t? Now remember, we want a distance formula for the red section only. So how do I do that? Well, you need to have, where is it at 7? What position do you have at 7? So x equals 7 is just the area of this shape here. So that is 1/2 height. Height is 20 times base 1 plus base 2. I'm going to use the trapezoidal formula, or you could use a triangle to rectangle. So base 1 is 7, base 2 is 5, 7 minus 2. And then this is 12, half of 20 is 10, 10 times 12 is 120. So x of 7, I guess, I'm guessing they're going to be okay with x of 7, but they probably want the 120 for that initial position. Then this here is the positional accumulation with the endpoint being unknown, because they did ask for x sub t. So they might want x of 7. And then you stop at the 120. They might want x sub 7, x of 7.1. And then you need to find out what the total distance traveled is from 7 to 7.1. And that's how you do it. Or if they want all the way up to like 9.9 or up to 10 even. Well, not really 10 because it doesn't include the endpoint, but anything in between there, and you would just have this function here, which is an unknown. Now, they do antiderivative it, and they do have all the simplification needed for a problem like that. And this would be wonderful, I'm guessing, for an answer. But I'm also guessing that if you have this step here, which I guess I'll write up here, 120 plus the integral from 7 to t of the velocity function, which is that equation right there, negative 10u plus 90. And of course you don't have to use u, you can use any variable in there. You could use an x, you could still use a t if you wanted to. It's a little weird to have an upper bound of t and a t in the function, but you could still do it. It really doesn't matter. So I'm guessing they'll accept this. That would obviously be the better answer. But that's how you do it. It's kind of a tricky problem to get that 9th point, and it is worth 2. So I don't think that they'll give you any partial credit for that. So I'll accept probably this one or this one right there, but it's hard to get that last point. Thanks for listening. Don't forget to give yourself a score out of 9 on the top.